It's regarded as a relic of the 20th century, but in truth, the space race never ended. The reigning champion of the Cold War era, the United States, came into the new millennium with the most advanced space program on Earth. But from halfway across the globe, a new challenger stepped up to dispute American dominance. On terra firma, the nation of China is the world's great rising superpower, challenging the United States on matters economic, diplomatic, strategic, and more. And if China has its way in space, then the United States will soon relinquish the top spot and hand over the crown to a new leader in the cosmos. What China's done. When we explore the prospect that China could become the world's leading superpower in space, we've got to start with a question of what China has already achieved. Certainly, the nation's distant history in space is impressive on its own. Its work kicked off all the way back in the 1950s when the forefather of the Chinese space program, Chiang Kai-shek, led the nation from a modest missile development program to an initiative meant to place China alongside the United States and the Soviet Union. By 1970, China had launched its first space satellite. By the 1980s, it had a reliable launch vehicle, the Long March 2C, that would eventually launch upward of 80 times. In 2003, the first Chinese astronaut, or taikonaut, in history rode through space for over 21 hours, and by 2007, China had sent its first probe to the moon. But rather than go through the process and explain the how of China's history in space, we're gonna focus on the what. What has China already achieved, and just how impressive is the country's space program today? In the mid-2020s, the crown jewel of the Chinese space program, and indeed one of the more impressive projects ever undertaken by a single nation in space, is the Tiangong. A permanently crewed, solely operated manned space station, the Tiangong is about a third the size of the International Space Station, but it's a far more modern take on a permanent orbital station. Made up of 3 modules, the Tiangong hosts multiple laboratories and runs dozens of scientific experiments at once, with over 1,000 slated to be carried out on the Tiangong at some point in the future. The Tiangong is fully operational and is expected to grow much larger over the next few years. As we talk about this in relation to superpower competition with the United States, it is worth noting that the Tiangong might not even exist today if not for the US Congress prohibiting NASA from collaborating with the Chinese National Space Administration, basically kicking China out of the International Space Station and forcing the nation to accelerate its efforts to build its own replacement. Alongside the Tiangong is the workhorse of the Chinese space program, the Shenzhou crewed spacecraft. A far more modern take on the Soviet-era Soyuz capsule, the Shenzhou is a single-use vehicle capable of ferrying up to 3 taikonauts to space on a given launch. Across over a dozen crewed launches, it's proven fully reliable thus far, and it's been launched twice a year, every year, since 2021. Operating alongside the Shenzhou is the Tianzhou, an automated cargo capsule that's used to resupply the Tiangong. Capable of carrying up to 6.5 metric tons of cargo, the Tianzhou has also logged a perfect mission success rate. Between China's crewed and uncrewed capsules, it's built a program that's perfectly capable of sustaining its space station indefinitely. China is also known to fly a reusable spaceplane, and although details on the spaceplane are hazy and no images have ever emerged, it's known to have launched and landed 3 separate times, most recently in September 2024. Just as important to China's success are its series of expendable rockets, the Long March family, that's now performed a total of over 500 launches to orbit and beyond. Over the last decade and a half, Long March launches have comprised up to a quarter of all launches to space each year, and the latest variants have proven to be highly reliable. The latest operational rocket, the Long March 5, is a heavy-lift rocket capable of transporting 25 metric tons of payload or 55,000 pounds to low Earth orbit. The Long March 5 was instrumental in building the Tiangong space station, and so far, it's proven a 100% success rate in mission launches. Meanwhile, China's workhorse rocket, the Long March 4B and 4C, has been launched toward orbit on 107 occasions, as at the time of writing, and has logged only 3 failures during that time for a success rate of over 97%. The Long March 6A has logged a perfect record across 10 missions since it took its first flight in early 2022, while the Long March 7 has suffered only a single failure in 17 mission launches, many of which were to transport the Tianzhou uncrewed cargo spacecraft. The small Long March 11 has pulled off a perfect 17 successful missions thus far in its service life. Then there are the long list of missions and operations that are ongoing across China's space program, transiting orbit far above our heads. Among the nation's major satellite projects is the Gaofen series, a group of dozens of high-resolution Earth imaging satellites that work hand-in-hand with atmospheric and near-space instruments to gather all sorts of useful data. Although the program is civilian-led under China's state-owned system, it's got clear military intelligence value, and it was the first to offer a specific sort of sensor that can detect camouflaged objects on the ground. Then there's the Yaogang series, a set of well over 100 suspected military reconnaissance satellites that support the Chinese armed forces. The Yaogang program is believed to unify a wide range of radar, electro-optical, and other sensor technology and give China a very clear picture of what's happening on Earth. The Yaogang satellite's capabilities are not known with much real confidence, but they make up an extensive space-based monitoring system rivaled only by a select few others. Unlike most remote sensor satellites operating in low Earth orbit, the Yaogang operates in a geosynchronous orbit, allowing it to hover over the same part of the Earth at any time, and specifically, in the Yaogang's case, to hover over the Indo-Pacific. China is the only advanced surveillance satellite system to offer imaging capabilities in this way. And next there's the TJS system, a series of about a dozen classified satellites that seem to be able to provide China signals intelligence and early warning alerts to provide intelligence on the rocket launches of other nations. China is very vague about what these satellites do and why they've been launched, but they appear to cover a range of different capabilities, possibly each even being unique satellites rather than members of the same series. One satellite called TJS-3 was detected in 2018, releasing a secondary object that, on 2 occasions, carried out maneuvers around its host, and ever since then, TJS-3 has made numerous close approaches to suspected American military communication satellites. Another set of classified satellites, the Xiyang, appear to be placed in all sorts of diverse orbits around Earth and are thought to be engaged in a wide range of imaging and other operations in orbit, while another series, the Shijiang, appears to cover programs that have helped China learn to carry out automated maintenance of its assets in space, as well as one, the Shijian-19, that successfully became China's first retrievable and reusable satellite when it dropped back to Earth in late 2024. Alongside its military programs, China's civilian space exploration programs have moved rapidly in recent years. The country's Fast Radio Telescope became the largest single-dish radio telescope on Earth when it entered service in 2022, and will now add an entire array of 24 more radio telescopes to enhance its resolution. Up in space, the country's hard X-ray modulation telescope has observed black holes, neutron stars, and more since it went operational back in 2017. The GCAM satellites, 2 X-ray and gamma-ray observing satellites that search for electromagnetic signals that accompany gravitational waves, along with a range of other celestial phenomena. Another telescope satellite, the Space Variable Objects Monitor, or SVOM, also works to identify gamma-ray bursts, although this satellite is a collaboration with the French Space Agency. In preparation for crewed lunar missions, China has launched the Qiqiao relay satellites to establish a frozen lunar orbit on the far side of the moon to support communications. China's lunar exploration program is going pretty swimmingly so far. After the launch of its first lunar orbiter back in 2007, the nation has generated an exceptionally detailed, high-definition 3D map of the lunar surface, tracked the locations and abundance of chemical elements on the lunar surface for future exploitation, and soft-landed spacecraft on lunar soil. China has operated multiple moon rovers, including the Yutu, which spent several months observing all sorts of stars while trundling around on the lunar surface, and the Yutu-2, which used a ground-penetrating radar to gather data about what lies under the lunar surface. China has returned samples from the moon on 2 occasions, and most recently a robotic exploration mission known as Chang'e 6 not only took the first samples from the far side of the moon, but also dispatched another rover, a tiny autonomous robot named Jinchan. And finally, China has begun its interplanetary exploration program, the Tianwen series of missions, with its Tianwen-1 mission to Mars coming up on half a decade in operation. Tianwen-1 was launched back in 2020 and has been in service ever since, studying Mars from orbit to ascertain all sorts of topographical, geologic, and atmospheric data. It also dispatched a Mars rover called the Zhurong in mid-2021, and when the Zhurong touched down, China became only the second nation ever to place a rover on the Martian surface, behind the US and only the US. All in all, China's space program today is so successful that it's already managed to make the 21st century space race into a 2-player contest. Russia, India, Europe, and other attempts don't even come close to what China's doing, and while the United States is still comfortably ahead on most historical metrics, China is closing the gap. But the missions that China's already added to the history books are just one part of the story, and to get closer to an answer on China's potential superpower status, we've got to take a look at the missions China is preparing for now. What China's doing. At this very moment, the Chinese space program is poised to make several massive strides, nearly simultaneously. From spacecraft design to rocketry, from exploration missions to scientific experimentation, China is in various stages of preparation on projects and initiatives that will take its space program to the next level. Perhaps most important of all is China's plan to push its taikonauts out of low Earth orbit, starting with the Mengzhou. The Mengzhou, formerly known as the Next Generation Crewed Spacecraft, is the successor capsule to China's Shenzhou spacecraft, slated to take over crewed flight responsibilities within the 2020s. Built in multiple versions, the Mengzhou will be provided to the Chinese space program in a specialized low Earth orbit variant, but also in a variant that's meant to take China to the moon. The Mengzhou is expected to be able to carry up to 7 crew members at once, comparable to the SpaceX Dragon 2, and it's intended to ride on the back of an advanced rocket with up to 4 metric tons of payload in total. As of late 2022, the Mengzhou has yet to actually carry any crew to space, but it's completed a pair of test flights and a wide battery of ground and atmospheric testing. The Mengzhou comes part and parcel with the Lanyu, a lunar lander that's expected to bring taikonauts to the lunar surface for the first time by or before 2030. China's lunar exploration program will expand on the work of the Chang'e series of missions, and while we'll address China's ambition to create a permanent lunar outpost shortly, its more immediate plans are just as impressive. China intends to use the Lanyu to transport 2 taikonauts to lunar soil, along with a 4-wheeled lunar rover designed specially for the demands of lunar driving. According to Chinese space program leaders, the lander has already finished development along with new, lightweight spacesuits that will offer massive improvements over China's current models. Elsewhere within China's ambitious set of plans, we've already touched on the prospect of expanding the Tiangong, but we haven't discussed the extra space station elements that will soon join it in orbit. That would be the Zhuntian, a space telescope under development that's expected to launch next year, 2026. Despite some delays, the Zhuntian appears to be a very impressive piece of hardware, featuring a 2-meter diameter primary mirror that will allow it to image up to 40% of the sky at once. That's a field of view up to 300 times larger than Hubble's. The telescope is a highly advanced piece of equipment, and it'll co-orbit with the Tiangong space station, even docking with it from time to time. And then there's the soon-to-launch missions of the Taiwan Planetary Exploration Program, intended to follow the Mars lander mission that's been ongoing since 2020. The Taiwan 2 mission is slated to launch in just a couple of months, in May 2025, and it'll serve as China's first mission to both return a sample from an asteroid and explore comets as well. The Taiwan 2 will collect about 100 grams of a sample from a near-Earth asteroid called Kamau-Aloea, using a tiny orbiter and a tiny sampler to get the job done. It'll be the first spacecraft to use a so-called anchor and attach method to collect a sample, proving a concept not yet executed by the Americans and Japanese. The Taiwan 2 spacecraft is already at its launch site, and a precise launch date should be set soon. After the Taiwan 2, you'll never guess, there's the Taiwan 3. Shock horror! Expected to launch in 2028. The Taiwan 3 will consist of 2 separate spacecraft traveling to Mars via 2 separate launchers to execute a complex sample collection and return mission. The 2 spacecraft will rendezvous in Martian orbit, with one serving as an orbiter that will eventually place the sample on a return path to Earth, and with the other serving as the Mars lander that will actually go down and get the sample from the planet's surface. The Taiwan 3 will search for Martian life signatures from a sample of about 500 grams of soil. In the field of rocketry, China's Long March series is on the cusp of rapid expansion, with several types of Long March rockets logging test flights over the last couple of years. The medium-sized Long March 6C rocket took its inaugural flight in 2024 and will soon take over many satellite launch duties for the PRC once it's ready to go operational. The Long March 8 took its first flight in 2020 and has just begun transporting payloads to orbit, whereas the Long March 10 is expected to serve as a super heavy carrier for China's anticipated crewed missions to the moon. Standing at a height of 92.5 meters or 303 feet, and capable of blasting 27 metric tons or 60,000 pounds into a translunar injection, the Long March 10 is expected to make its first flight next year in 2026. The Long March 9 stands even taller at 114 meters or 374 feet and can bring a full 54 metric tons into translunar injection or 44 metric tons into a trans-Martian injection. That's 119,000 pounds to the moon and 97,000 pounds of payload to Mars, respectively. The Long March 9 will take its first flight in 2033, according to current projections from China, and it'll fill basically the same role as the SpaceX Starship, including full reusability. On the subject of programs meant to rival SpaceX, 2024 saw the launch of a program known as the Space Sail Constellation, a planned network of over 15,000 satellites that will one day provide global internet coverage. The Space Sail Constellation is a direct rival built to oppose the Starlink system, and while it's not yet reached a level of coverage comparable with Starlink, it is already in the process of launching as batches of small satellites. After an initial launch in 2024, a total of 54 satellites were launched that year, with the goal to place nearly 650 into orbit by the end of 2025. According to observers on the ground, the Space Sail Constellation uses satellites that can be observed with the naked eye, and it's not the only mega constellation that China is planning. The nation intends to build two other mega constellations, the Gullwing, also a global communications service, and the Crane 3. The Gullwing mega constellation got its first set of satellites delivered at the end of 2024 and a second set launched in February 2025. On its lunar program, China intends to launch two more uncrewed Chang'e missions in parallel with its manned lunar orbit and landing attempts. The Chang'e 7 mission will launch in 2026 and explore the lunar South Pole for the presence of resources that can be exploited later, while the Chang'e 8 may bring 3D printing infrastructure to try and test build the technologies and pieces needed to set up a scientific base and resource extraction operation on the lunar surface. Around that same time, China will be gathering data from far-flying space probes called Shenzhou, formerly referred to as an interstellar express, expected to launch at some time in the next year or two. The Shenzhou probes will get a quick gravitational assist from Jupiter before flying out to the edge of the solar system and beyond. One of the probes may attempt a flyby of a dwarf planet named Quasar, about 1,100 kilometers in diameter and located way out past Neptune, while the other will pass near Neptune and its moon Triton in the late 2030s. If successful, these would be the first non-American spacecraft to leave the solar system and just the fourth and fifth probes ever to maintain contact with Earth after traveling out that far. And in a much more earthly metric of space superpower status, China is well on its way to positioning itself as the leader of a broad international coalition for future space programs. China's recently stepped up its cooperation with Russia, committing to major lunar projects that we'll discuss in just a moment, as China has started to position itself as a long-term leader for projects that Russia can expect to be a part of. Nations from Azerbaijan to South Africa, Pakistan to Venezuela, and Egypt to Brazil have signed paperwork with China to collaborate in space in future years. China maintains space tracking stations in Australia, Kenya, Sweden, Namibia, and elsewhere, and it's launched satellites on behalf of over a dozen world nations. Dozens more are customers for Chinese space-related projects, and the nation has engaged in scientific development and design collaborations with other countries on a range of programs, spacecraft, and other initiatives. Taken together, China's slate of upcoming missions mark it as the only other nation engaged in operations of even remotely the same scale as what the United States is able to do. Not only that, but China's balancing a wide range of programs at once, most of which seem to be making good progress and most of which seem as if they've got a strong shot at success. The nation is positioning itself to be a leader in modern space exploration on the global stage, and it's on the cusp of ensuring that it'll be other nations' go-to partner where space operations are concerned. Notably, it's been able to leverage advanced technology and the perks of observation to do a lot more work at a much more rapid pace with much fewer stops or stutters than the United States was able to during the Cold War years. If we're handing out trophies and awards for best space program, then of course we'd have to take into account the more limited technologies available when the US ran many of its most famous missions, and we'd have to acknowledge the many drawbacks and frustrations that come with being the first to do anything. But we aren't asking who's been more impressive or had the tougher road. We're asking whether China is poised today to be the world's next space superpower. And on that metric, historical context simply doesn't matter. What China aspires to do. We've discussed the recent past for China's space program. We've discussed what it intends to do with the present moment, and now we've got to turn the clock forward to take a look at China's future ambitions. After all, in space, perhaps more than anywhere else, progress and ambition are everything, and no nation that intends to sit on its laurels could ever become a space superpower, even if its capabilities are impressive today. China, however, seems to have no desire to exit the space race early, and its lunar ambitions are the ones that have caught the most impressive headlines over the last few years. China's Langyu lander is just the start, and according to the Chinese government, moon bases may be coming next. Starting in 2026, China intends to construct the International Lunar Research Station, a joint project carried out with Russia, South Africa, Thailand, Egypt, and several other world nations. The lunar station will be either orbital or located on the lunar surface, possibly both, and will play host to a wide range of experiments and exploration efforts. The base is intended to consist of numerous scientific support and transportation modules with the intent of being crewed by or before the year 2036. That base will be located near the lunar South Pole and will be built out to its full form by around 2045. China ultimately intends to collaborate with up to 50 other nations on the base, according to statements made in mid-2024, and has already crested past a total of 10. The nation appears intent on utilizing natural resources that can be mined from the moon and appears to hold ambitions that would way exceed what one single moon base could possibly achieve, raising the possibility for China to engage in solo endeavors at the same time. China's intentions have sparked international debate around the question of resource extraction from Earth's natural satellite, and those debates are tending towards perhaps not a full endorsement of China's goals, but an international agreement that China can certainly work with. Of all the nations on Earth, China is quite clearly the one with the most well-developed plan to settle the moon in the long term, with the US-led Artemis program struggling to catch up. And where China's lunar ambitions lead, its Martian ambitions follow close behind. According to Chinese officials, the nation intends to send its first crewed mission to Mars by the mid-2030s, with regular manned missions coming after that. Those missions will aim to establish a sustainable long-term presence there, using a platform that robotic missions will first build to support human life using extracted water and other resources, and that humans will then expand from an orbital outpost to a surface base. Chinese leaders have, in the recent past, referred to what they call an iconosphere, an operation powered by a large fleet of nuclear-powered reusable spaceships to run shuttle trips back and forth to Earth while establishing a comfortable and continually expanding human presence on the surface. China's long-term ambition is to create a Moon-Earth economic zone, estimated to eventually be able to transit the equivalent of $10 trillion in resource extraction per year, and from there, it's hard to even conceive of the deep space missions that might be possible. Across the rest of the solar system, China intends to dispatch probes to explore various celestial targets. The Tianwen 4 mission is slated for launch in 2029, eventually rendezvousing a probe with Jupiter and its moon Callisto by 2035. The Tianwen program also has plans in place to probe Uranus, although anybody looking forward to that will need to wait until 2040. A potential Taiwan 5 mission may place a more permanent orbiter around either Uranus or Neptune. A mission called the Solar Polar Orbit Observatory is expected to launch in 2029, sending an observatory spacecraft that will examine the sun's poles, while China's recently announced plans to build a massive solar power station in space using parts sent up by heavy-lift rockets and pieced together in orbit. That initiative would build a 1-kilometer-wide solar power station that would transfer its power back to Earth by beaming it via microwaves. The project's lead scientist has said, quote, "The energy collected in 1 year would be equivalent to the total amount of oil that can be extracted from the Earth." And then there's the Tianlin, a successor space telescope that will follow the one China plans to launch within this decade. The Tianlin would place into orbit a massive mirror, about 4 to 6 meters in diameter, just a bit smaller than that of the James Webb Space Telescope. Using ultraviolet, near-infrared, and visible light instruments, the Tianlin will search for rocky planets and analyze them, looking for biosignatures that would indicate the potential presence of living creatures. The Tianlin is expected to include what's called a coronagraph, an internal mechanism to block out the brightness of stars and let exoplanets be analyzed much more directly. The Tianlin design offers major improvements over JWST, and it'll reach orbit long before a roughly equivalent telescope from NASA, the Habitable Worlds Observatory. The Tianlin isn't known to be an official project yet, but it appears to be close. China's also going to launch an observatory called Earth 2.0, expected to enter orbit in 2028, that would use 7 optical telescopes to observe about 2 million stars. 6 of those telescopes will analyze the Cygnus and Lyra constellations using data generated from the Kepler telescope and search for exoplanets, while the 7th telescope will use a technique called gravitational microlensing to try and observe rogue planets for the very first time. Whether all of this will be enough to put China firmly ahead of the United States isn't certain. The US has its own long-term ambitions in space, although many of them are a good deal less developed than China's, and they're held by a nation that's been proven somewhat less able to keep on budget and on schedule than China has in recent years. But the question we're here to ask isn't the question of which nation will ultimately win this phase of the global space race. The question is whether China is the next space superpower. And the answer, if all continues to go to plan, is, well, yes. By China's own public explanation of its ambitions, the nation seeks to be well on its way to both lunar and Martian permanent bases within the decade. It intends to bring together global coalitions of partner nations to organize an entire worldwide space industry around Chinese technology and capabilities. Beijing's goal isn't just to plant flags on celestial bodies like the American programs of the Cold War. The goal is to colonize, to exploit resources, and to settle space for the long term. That's a race that the United States seems ill-equipped to actually win right now, and it's a race in which China, drawing on what we can only describe as greater ambition, seems to be pulling ahead at. And we've got to be very clear here in emphasizing that none of China's ambitions are guaranteed to become real, from technological setbacks to geopolitical complications here on Earth to the necessary drawbacks of a strained economy and a changing population. There are no promises for China if it remains on its common course. But it's China that has the clearest concrete plans for the future. It's China that intends to push the bounds of what's possible in space, and it's China that seems to be best equipped to actually make it happen. If a nation that fits that description isn't the next space superpower, then quite frankly, nobody is. Thank you for watching.